Tech giants spend billions of dollars on alignment, the safety guardrails designed to keep their artificial intelligence models from causing harm. Bypassing these safeguards is usually assumed to require high-level technical effort. We imagine hackers using gradient optimization or token manipulation to break the rules. These systems are engineered to block instructions that lead to physical harm, specifically screening for CBRN risks, chemical, biological, radiological, and nuclear hazards. The security of the modern AI industry rests on the assumption that malicious actors will primarily attack these models using advanced software engineering. A recent joint study by the DexI Icaro Lab and Sapienza University tested an entirely non-technical attack vector. The researchers took explicitly harmful instructions and rewrote them as standard poetic verse. They embedded the same intent inside sonnets, limericks, and rhyming couplets. Using a single text message without any iterative refinement, this method bypassed the safety filters of the world's most advanced frontier models. The barrier to bypassing these safeguards has shifted from complex code to basic human literacy. To see how wide this vulnerability stretched, the researchers tested adversarial poems across 25 different models across 9 major industry providers. This chart shows the results. Handcrafted adversarial poems achieved a 62% average attack success rate across the entire testing group. Certain architectures proved highly susceptible. The open-weight llama model family hit a 70% failure rate. Susceptibility reached its peak with the Gemini models, where success rates consistently reached between 90 and 100%. To prove this wasn't just a quirk of clever human writing, the team used an automated system to generate the verse for 1,200 safety benchmark prompts. Even without human fine-tuning, the success rate remained 18 times higher than standard prose. These results indicate a structural vulnerability embedded across the AI industry, regardless of the specific provider. This vulnerability exists because of how safety classifiers operate. They function as pattern-matching heuristics, scanning user inputs for the direct, prose-like structures that typically signal harmful intent. Poetry breaks that expected pattern. It uses metaphor, shifts syntax, and hides the core instruction inside layers of narrative framing. When harmful intent is encoded into iambic pentameter, the patterns stop matching. The model's refusal circuits never fire, because the input does not look like the prose it was trained to catch. Safety training teaches a model to recognize and reject the specific shape of a threat, leaving it unable to identify that same threat when the form changes. The study also uncovered a counterintuitive trend. Smaller, less keepable models were sometimes more secure against poetic attacks than the massive flagship models. This is a result of how flagship models are trained. To improve their capabilities, developers feed them massive corpuses of human literature, art, and history. This literary training teaches the AI that poetic context is inherently creative and benign, rather than a genuine query. A larger model's superior ability to follow complex poetic instructions directly increases its susceptibility to this type of manipulation. By teaching artificial intelligence to interpret human culture, we inadvertently created a pathway for its own manipulation. These findings suggest a structural limitation in current alignment strategies. Standard reinforcement learning from human feedback is proving brittle against variations in stylistic form. Relying on the model itself to decide whether or not to comply creates a single point of failure in the safety stack. Defense strategies likely require a shift toward architectural defenses, using independent input classifiers and layered monitoring that operate outside of the model's own logic. Future evaluation protocols and safety benchmarks must test against stylistic manipulation, including allegory and song, rather than relying on plain prose. Safety frameworks that only evaluate the what of a query, ignoring the stylistic how, contain a verified gap in their security. 2.5 millennia ago, Plato argued for removing the poets from his Republic. He believed mimetic language had the power to distort judgment. Poetry is one of our oldest technologies for encoding meaning in non-literal forms. Humans have spent centuries developing the capacity to say one thing while meaning another. That historical susceptibility to metaphor is now mirrored in our most advanced language models. This means the most universal threat to trillion-dollar artificial intelligence is the inescapable legacy of our own literary heritage.